welcome, hello. This is our third webinar in the series of Flex Your Power. This one is going to be focusing on wind and storage, which is a fantastic topic. By way of background of these webinars, they've been designed to engage our Flex provider community and to share insights into the potential value that can be unlocked by participating in local Flex markets. And most importantly, we have special guests who will be with us to share their stories and their own experiences in taking part in these markets, which I'm really excited to hear about as well myself. So at the end of the session, once we've had all of the speakers, we're going to have a Q&A. So please use the chat function to do two things. One, say hello, say who you are, and welcome yourself. And also just we can log questions there as well, which we'll come back to at the end for the Q&A. So use the chat function, please. And as we kick off, I also want to mention that this is a webinar co-organised by Piclo and RenewableUK, and we're really excited to work with our partners. I'm going to pass you over to Jonna, who's going to give you an overview of the markets and policy. So over to you, Jonna.
Thank you, Alice, and good morning, everyone. My name is Jonna Vitanva. I'm a senior policy analyst at RenewableUK, focusing on storage and flexibility. And I'm aware that some of you might not be so well aware of RenewableUK and who we are, but essentially we are a trade body representing the wind industry in the UK, and increasingly technologies such as storage, both short and long duration, as well as green hydrogen and wave and tidal. Today, I was asked to do a brief policy update and provide an overview of the work that RenewableUK is doing in this space. And I'm not going to present any slides today as my other presenters. So I'm just going to talk to that bit. And I think probably everyone on the call today is well aware that we are in the period of energy transition. So we are moving away from the old way of doing things and relying on fossil fuel-based large power station approach to how we manage the energy system in the UK to a much more decentralized, decarbonized, and digitalized way of doing things. And as part of that, renewables will play a critical role in this as we're moving to achieve net zero by 2050 and also achieve the ambition to fully decarbonize the power sector by 2035. We are going to see renewables like offshore wind, onshore wind, storage at full scales, as well as hydrogen play a bigger role in that energy transition. And what we have seen in the policy space over the past year is nothing but dynamic. We have seen increased focus on whether we have the right market frameworks and market arrangements to make that energy transition work for the technologies that we will have in the future. And as part of that, essentially the government has launched the what is called the review of electricity market arrangements, which is really looking at everything from the wholesale market to the current key procurement mechanisms that we use in the UK, such as the contracts for difference, to the balancing and flexibility markets that we also employ in the UK, and whether they work essentially for this vision of the future by 2035. We have also seen an increased push towards a much more strategic approach of how we manage the grid build out and reinforcement, and how we manage the planning and consenting regime for the technologies that we will have. And as part of that, we have seen the announcement that the electricity system operator would be transitioning to a much more independent future system operator that will have the remit to have a greater focus around strategic planning and design of the future electricity system. And even more recently, as last week, the government published the long-awaited Connection Action Plan to address the growing concern across the industry and the sector around the connection delays and how we manage and better the connection queues in that space. And the last thing which I wanted to mention in that bigger picture context really is the increased focus on supply chains, sustainability, and circularity for the raw materials that we will need in order to deliver the technologies of the future, such as wind and storage. So in the offshore wind space, we have seen the consultation by government on the Sustainable Industry Awards, which would really link up with how we deliver the supply chains with the key procurement mechanism, which I mentioned, the contracts for difference. And as recently as last weekend, we saw the government publish their battery strategy on supply chains, which really commits to development of a sustainable supply chain for batteries in the use of electric vehicles, as well as grid-scale storage that will ensure that we have that by 2030. And in terms of how that overall narrative is reflected within the policy work of what Renewable UK is doing, on the market reform side, earlier this year, we published a report looking at the assessment criteria for the options for reform of the contracts for difference mechanism. And very much linked to that piece of work is the way of how we optimize the resources which we have on the ground better. And currently we are doing a bit of work around collocation and hybridization of those technologies, such as wind and solar. What are the barriers there, and how we can maximize the benefits and opportunities from that. And very much linked to that space of optimizing the resources, the narrative around digitalization, making sure we have the right frameworks to transfer data between buyers of flexibility and sellers of flexibility, or the industry. And as part of that, we have seen the electricity system operator introduce the enduring auction capability platform recently, which has made a huge difference in the way of how, at national level at least, we are able to optimize how we procure different products and different services across the technologies on the ground. And we will see a much bigger push at distribution level, as well as local level, as well as national level, to move towards the space of platforms with capabilities that can deliver for the market as well as the system. And the second and last piece, which I wanted to mention of importance to us, relates to that bigger narrative around system design. So we have seen the transition to FSO, and that would be crucially important to the work that Renewable UK would be doing in that space, especially with the Connection Action Plan, and making sure that this is deliverable in the future. So I'm going to stop there. But thank you. Happy to answer any questions afterwards.
Thank you so much, Jonna. It's great to hear the policy update there, and what I like to hear especially is just how there's lots of people all trying to solve this problem at different levels of, size of grids and voltage, from the small to the big, and the size of assets as well, because there's no one size fits all to pushing forward with the transition. So I'll just give a quick brief update of how PICLO is taking part in this transition as well, and then I'll hand over to our second speaker. So I'm assuming a lot of people kind of know who we are, but we're a software company that are focused right now in helping the UK transition towards net zero. I think we're all very familiar with the problem about how grids are at capacity at certain points, and how we should be using more flexibility to optimize the grid infrastructure. So instead of investing millions of pounds in potentially future redundant assets, we would like to help, and we are helping distribution network operators, and also for certain things the ESO as well, use flexibility instead to help optimize the grid efficiency when they've got capacity constraints. And so PICLO is here helping coordinate where the network needs something, and local distribution connected assets can provide it. And that's our marketplace, which some of you maybe have used to win contracts with some of our network operators customers. So just briefly on what services Piccolo provides. If you haven't got an account with Piccolo at the moment, you can go on, and what you'll see there is how we bring together multiple system operators to purchase flexibility. Often they're focused on local constraints, so we have a map that really visualizes where those particular issues will be, and then we can help you, distinguish between which of those competitions you might be able to take part in. If you upload your assets, we'll be able to do a series of automatic matching that will help you figure out which of these competitions you might be able to provide a resource to. So we're currently working with 4 grid operators. And also we're running the local constraint market for National Grid ESO, and there'll be more. I'll give a little update on which specific markets are live right now in a couple of slides. So first of all, if you haven't used us, just a quick overview of the process. So on the screen, you'll see that we're all familiar with the journey of winning and then being procured and being utilized for flexibility. But essentially, Piccolo is being designed to help the network operators publish their needs, help you qualify, which is obviously can be quite a complicated part of the journey. That's both the business qualification, also the technical asset qualification. Then we help run those auctions, whether they might be fixed price or competitive auctions. We've got a flexible market that helps run any type of that. The system operators will then use us to do some certain analysis and run a market clearing algorithm, selecting the best bids, and then those who win those contracts are then taken through with and then provided with dispatch, and after dispatch we can produce performance analysis and invoicing responses as well. So Piccolo's been working really hard to build out services for the whole end-to-end. You might have only used us so far for the procurement pieces, but different members of our customer base are also using us for further afield and all the way into invoicing. So if you've taken part in the local constraint market, you might have also been dispatched by Piccolo and also provided invoice data as well. So it's grown a lot since we first started 5 years ago, and we're really excited to offer the end-to-end service to more customers. So one other thing to mention about this is that we've always been designing our market function with the knowledge that different flexibility providers and market operators are at different levels of digitalization of their own systems. So you can take part in Piccolo both using just simple UI methods like file uploads that you can go and collect or create. But if you've got the system and the availability, you can also do nearly all of this via APIs and automate it. And that will massively speed up your ability to fast track getting qualified and also make sure that bidding happens in a timely manner. So that we've got extensive API documentation, which if you haven't seen, I can make sure I share a link in the chat also later, and you can also check that out. So why should you participate? And this is kind of like the whole topic of the moment. It's about helping the local grid operators optimize their networks, and you guys also can add a little bit of revenue for those assets that you've got connected. We've got more things in the roadmap to help surface those revenue opportunities. So hopefully next year we'll be showing you some more exciting features around that. So do stay tuned. But there are revenue opportunities mapped on Piccolo right now, so you can see them. And it should be quite simple. We also have a dedicated customer support team. So if you ever have any issues, we are always here to support. And we've also just recently launched a training platform to help new and even sort of more experienced flex providers really improve their skills on certain parts of it, like how to get the easiest way of uploading assets, or how to make sure they do qualify for the most competitions. So if you're interested in that, we can also share a link to that in the chat as well. So the last thing to say is that our system operators host both long-term and short-term competitions. And so, for example, the local constraint market from the ESO, that is a short-term competition. So that's something that you need to get qualified in ahead of time, and then they'll be running day ahead or intraday competitions. And our local networks so far have been focused mostly on long-term competitions, which you'll see they'll have like a much longer lead time to that. All of that information is on Piclo, so you can go and find that. Even if you're not logged in, it's just at picloflex.com right now. So this is what's live at the moment, and there's a range of opportunities depending where your assets are sited around the UK. Again, that's why we've got the map to help you sort of visualize that. We've got open qualification for Electricity Northwest at the moment, and open qualification for SPEN, bidding coming up soon in December. There's always the local constraint market, which has a sort of a continuous open qualification. The competitions are then run separately, so you do need to get qualified ahead of time for that local constraint market one with the ESO. There are, for Northern Power Grid, there are some competitions up, really just looking for interest at the moment. I think Northern Power Grid, they haven't set a bidding open date, so they just want to know who's there. And this is an example of what Piclo is really trying to help match that, like who is there, who's potentially available to provide flexibility. So even if you're not 100% sure, it is worth adding your assets to be able to show the system operators where they are and if you might be interested to take part. It really helps start that conversation. And for the UK Power Networks recent ones, their qualification's now closed. So those of you who might have already qualified, your bidding will be opening on the 11th of December. So there's quite a lot happening at the end of this year. And if you're not sure exactly what's happening and what you can take part in, do always just email Piclo Flex. We've got a support email, and we can help as well. So. Where to find that information? Well, if you're already a member of Piclo, you'll probably get plenty of emails for us. But each of the system operators have profile pages. We've got support, like I've already mentioned. The new Piclo Academy, which is about helping you guys train and be really, really confident on using the tools. So when you get those time limited moments, for example, bidding windows, that you're confident and ready to go for it, and you've got everything you need. And there's lots of material online about being ready, and webinars and everything. So the next slide is just a final message from us, which is about how we've just announced we're doubling down on our functionality for flex providers, and we're really excited to announce Piclo Max. So Piclo Max is about Piclo being able to provide even more to flex providers like yourselves, and this is why running webinars like this is really important. We've been listening to you for years, and we really want to provide you the best service we can. What we're doing with Piclo Max is bringing more markets into one place, because we know that being able to access multiple DSO markets has been really useful, which is what we've been doing in Piclo Flex for a while now, but we want to add more markets. So we'll be connecting into other markets. We'll also be putting in more functionality in here to help you guys and fast track your submission into more markets. So exciting things in the future, like automatic bidding, and more support with APIs and everything. So there's a lot of interesting things going on in Piclo at the moment. If you're interested to know what they are, I think probably best reach out and we can have more specific conversations as well. So there'll be more news on Piclo Max coming out next year. So I think we are handing over to speakers next, and the first speaker is Abbas from EDF Renewables, and really excited to hear about the case studies that we have in this one. So over to you.
Thanks, Alice, and thanks to Piclo for having me on this webinar, and hello to everyone else tuning in today. My name is Abbas Darwala. I work as a revenue originator at EDF Renewables, where I look at new markets and what additional services we can provide from our assets, essentially to capture new revenue streams. And one of them has been the local constraints market that we've participated in with one of our wind farms. And that's what I'll be talking about today. Before we do that, just a brief introduction into who we are. So next slide, please. EDF Renewables, what do we do? We develop, build, and operate renewable energy generation. That includes onshore, offshore wind farms, solar, and also battery storage technologies. We have about 1.2 gigawatt in operation, and we have footprint across England, Scotland, Wales, and Ireland. As you can see, there's primarily it's been onshore wind, but we've got 2 offshore wind farms operational. And also, as of the past couple of months, we actually have 2 new energy storage assets, which are 2-hour assets, which have gone online as well, started their commercial operations, which have not been shown on this chart here. But in addition to grid-scale technologies, we also provide on-site generation solutions like rooftop solar, ground mount solar for large commercial and industrial consumers. Next slide, please. As I'd mentioned, we'd be focusing on our participation in the local constraint market that was briefly mentioned by Alice in the previous flow description. So why did we choose the local constraint market? At EDFR, we actually have the benefit of operating a diverse set of technologies, and we also operate large transmission connected wind farms. And as a part of that, we do have experience, operational and commercially, being in the balancing mechanism. For those who don't know what that means, it's a balancing mechanism is a tool that National Grid uses to manage or match the supply and demand, and also manage constraints on the grid and ensure that it operates in a healthy manner. So that ties into the second point as well. We do understand that there is value in this flexibility. So the whole idea of a wind farm actually being asked to turn the generation down to manage constraints was not completely foreign to us. And this market allowed the wind assets which were not participating in the balancing mechanism to then also participate and be available for this. Third point is around it is a service that was eligible to us compared to the rest of the flexibility market services. So this service essentially just looks at turning down generation, and wind farms are capable of doing that. They're not capable of increasing generation because they often just run at the max that's available. So generation turn up wouldn't have been possible. So this service fit us, and it was actually located in the right zone that is actually constrained, which is between the boundary between England and Scotland. And overall, it provides the system benefits of relieving those constraints in the grid in a cost-effective manner. Let's get a bit specific then. So on the next slide, we've basically just summarized what our experience has been in participating in these trials. It was a 38 megawatt wind farm. It's called the Long Park Wind Farm, which is located in the constraint zone. Between July and September, we participated in 6 days with 6 different competitions. One was an intraday, but primarily our focus has been on the day-ahead competitions. And through those bids, we were able to achieve around 16 hours of curtailment with capacity averaging around 4 to 13 megawatt. Zooming in a little bit further on the next slide, we've basically tried to deep dive into one specific day of this trial. The local constraint market service runs from 7 a.m. until 7 a.m. the following day, and we bid in for each half hour. And on this specific day, we were basically contracted 3 hours during the day and 3 hours overnight. The contracted value varied between 2 megawatt to 6 megawatt, and that was based on the wind forecast for that specific day. So that sets the context, but let's lift the hood and see what actually needed to be done to make this happen. So the next slide talks about how we made it happen. There were 4 major teams involved. Let's start with the bottom left, home turf. That's the team that I work in, revenue optimization at EDF Renewables. Our responsibility was identifying the right asset, getting the company qualified onto the PCLO platform, registering our assets, signing the relevant contracts, and managing those. And once that was set up on a day-to-day basis, it was keeping an eye on the competitions, and we were responsible for bidding in and at the same time also for the settlement. Just on the right side of that is our sister company EDF Energy, and they were the PPA counterparty. Essentially, through a power purchase agreement, all the volume that was generated from this site would then be passed on to EDF Energy to then access the wholesale market and then trade that. In the LCM, we were asked to actually turn down generation, so the volume would not actually pass on to EDF Energy, and they had to be informed for that so that they could then manage their trading positions. On the top right, we have the control center, and this is the center that has 24/7 monitoring capability. They carry out the remote operation as well, switching on and switching off, and they are located in France. So this was the team actually that was responsible for accepting the instructions through the Piclo platform and then actioning those dispatch in the actioning that dispatch on the wind farms and making sure that they were basically they were switched off on the right time and they turned back on once the LCM window ended. And coming a full circle back to home turf, it was the EDF Renewables on-site maintenance team that also had to be kept in the loop. These are the technicians on site. If the site went off and they were not aware of it, they think something's wrong and they try to go on and try and manually restart these turbines, and we would not want that. So as such, they also had to be informed. So the bottom left and the top right were the key actioning parties, and that's why they've been underlined. So these were the two parties that were responsible for taking action, whereas the other two parties had to be informed for this to be effectively carried out. So yeah, these are the four pieces of the jigsaw that had to come together to effectively participate in this service, and it was delivered in a smooth manner. And that is what we tried to achieve in this trial, to understand this better. So reflecting on this, there's a few key pointers that I wanted to share from our experience, and that's the next slide. Firstly, we identified one asset, and that's what we trialed with. But at the same time, we've identified multiple assets. And to enable our participation, we think integrating with the APIs was quite key as such, because the process would involve a lot of manual intervention. And as a result, we've tried to, both those parties that are involved in the action have been working with Piclo to integrate with APIs to ensure that we can smoothly bid, smoothly accept the dispatch instructions, and also carry out the settlement. So it avoids a lot of the manual work and any kind of human error that may be involved in this process. There's a lot of data around the competition that gets published by Piclo on their data hub, and it's great to analyze that because that gives awareness of who the other participants are, what level of capacity they contract into it, and where they're pricing themselves. We think it's really important also to engage the local site teams. As I'd mentioned, obviously we don't want them to take any action that would restart those turbines during those LCM windows. But at the same time, if there is any sort of maintenance that needs to be carried out, if that can be optimized or those timings can be shifted during the LCM windows, that's also something that can be done through this and can create additional value overall. And the last point may seem obvious, but it's still worth iterating. It's we need to stay agile and adapt to this evolving market. There might be new participants that come in, the prices may change, and we also need to analyze what is the technical impact of starting and stopping these turbines. So these are the things that we need to continuously keep an eye on and be able to adapt to that, and therefore staying agile is one of the key tips that I'd like to share. So yes, that summarizes our experience. Hope you found that useful, and I'll hand the stage back to Alice.
Thank you. Yeah, that was a really, really interesting insight into your journey. And I agree. I think putting the effort in for the APIs early is going to help participants really like create a smoother journey for markets and optimize things. So I would second your point about the APIs. So we have a second case study. So I'm going to hand straight over to Jonathan, and he can introduce himself and the case study he's going to talk through. Over to you, Jonathan.
Hi, thanks, Alice. So I'm Jonathan Mann. I'm Technical Sales Manager here at Connected Energy. So I'm going to, we're from a different side of things, really. So we're a technology provider of battery storage systems, and I'm going to explain a little bit about what we do, where we come from, where we're going, and then give you some examples of the systems that we've got in the field and what they're actually doing. So next slide, please. Yeah, so there you go. A little bit about us, our solutions, and how we can provide flexibility, but also how that flexibility and the way we operate on site can be used in different ways. Okay, next slide, please. So yeah, we've been around for about 10 years. We are innovators in battery energy storage because we are using second life electric vehicle battery packs, and that's where we've come from. So next slide, please. And the reason we're doing this is, everybody's well aware of the energy transition and the reason we need storage in our electrical system, and that's one of the key points that we are engaging with. And the second one is the quantity of electric vehicle batteries that are going to be around. Maybe not now, although there are reasonable numbers now, but by the end of this decade there will be huge quantities of second life electric vehicle batteries, and we're trying to enable a circular economy and add value to those batteries before they go to recycling. So next slide, please. So our current solution, and bear in mind that we're working with batteries that went into the EV market 6 or 7 years ago. So as we get supply of newer batteries, our technology and our solutions will be changing. So currently we have a small system, so it's suited to behind the meter applications. It's a 300 kilowatt unit with 360 kilowatt hours of energy, based on some Renault Kangoo battery packs. There's 24 battery packs in each system, along with the power electronics and control systems. And really it's the way that we are able to manage battery packs that come to us with slightly different states of health, and have been used slightly different ways, and some might have been charged fast, some slow, etc. How we do that is our sort of unique selling point. So we can use these systems as a single system, or we can use and sort of combine up to 3 on any one point of connection, up to 8 on any one site. So that's the systems we've got now. There's a little bit more detail about the size. It's a 20-foot shipping container, and it just connects to a standard sort of 3-phase power supply. So on the next slide shows where we're heading to. So again, based on that quantity of EV battery packs that are going to become available, we are aiming for bigger systems. So next year we will be deploying a sort of modular system that will be 1 megawatt and 1 megawatt, 1.8 megawatt hour, but then we will add extra components to it, and it'll end up 2 megawatt, 7.2 megawatt hours. And that is the next step on our journey to being able to provide a proper grid scale front to meter, multi-megawatt system using second life batteries, which we are aiming to be able to do within the next sort of 2 to 3 years. And this next slide shows where we have some of our systems deployed. We've currently got about 30 systems in the field, mostly in the UK, but also several systems in Europe as well. And they are all doing slightly different things depending on what the site requirements are. Next slide, please. So yeah, so we'll run through a couple of the different case studies that we have, showing the different ways that these systems are used. So Dundee City Council are leaders in the use of electric vehicles. They've been pushing very hard on this. So we've got a few systems there at a couple of different sites, and we're just looking to get a new site for them now. The main use of these battery systems for Dundee is to both optimize the solar PV use, because they've got solar canopies on these sites, but to manage the import capacity to make sure that the charging units don't overload the supply. So we're managing those peak loads from the EV charging. So that's one of the key use cases that we see for the batteries. Next slide, please. This is a smaller EV charging example. So this is a site in Europe, and it's 2 50 kilowatt chargers, but the supply capacity is only 35 kilowatts. What we're able to do with the battery is to manage that supply capacity, and you can see from the two graphs there that the top graph shows how the actual site demand doesn't, that's a sort of blue line, and that doesn't go above the 35 kilowatts, whereas the actual energy delivered to the chargers peaks at 80 kilowatts. And that's the sort of an example of what we can do with one of these batteries. Next slide, please. So we've got a couple of systems with West Suffolk Council, and these are providing something slightly different. They are providing solar optimization. There's PV on site, and they're acting as a showcase of what's possible, but they are also generating revenue from grid services. So we see the sort of flexibility in two ways. We can offer the client and provide flexibility on site for their own energy and power consumption, and they can manage how they use that power on site. But also we can provide flexibility into the flexibility markets through grid services through aggregators. So this is what the Mildenhall site is doing. And then next slide, please. There's a site called The Hold, which is in Ipswich, which again is doing something very similar. This one, I don't think there's PV. It's just minimizing the peak loads on the site, but also providing grid services through an aggregator. So yeah, providing some revenue there. And then this is a graph showing how the battery is taking signals from the aggregator and then is being dispatched. And you can see the state of charge and the power delivered on those two graphs. So over time, the state of charge is generally dropping down slightly, but it's still delivering power into those grid services. And all of our systems are capable of accessing, technically they're capable of accessing any of the current grid services markets. Okay, next slide, please. There's a new market which we're seeing as being quite interesting because it sits very well alongside the solar PV optimization. So solar PV optimization, probably 3/4 of that is done through the summer months, a bit in the spring and the autumn, very little in the winter. And the demand flexibility service operates through the winter months. So it gives the batteries something else to do to layer up the revenues and provide that turn down for a site to access these revenues. And that's something we're quite excited about. Next slide, please. Cranfield University is one of our favourite sites. So they've got 3 of our systems. The systems are all they're not all together. They're at different parts of the campus at Cranfield. One is located at a solar PV farm. One is at their water treatment works, and one is at an energy centre. And different times of the day, these systems can be doing different things. So, one can be optimizing the solar PV and storing some of that excess. It can be reducing peak demand at the energy centre and the water treatment works. And at other times of the day, they can all be sort of aggregated together and used and controlled as a single system to provide grid services. So next slide, please. So yeah, you can see the 3 different systems there, and we will optimize the use of those through our software and allow them to perform both the site optimization but also the access to the grid services markets. And next slide, please. And these graphs show how so the top left, top right, bottom left are graphs from each individual battery. And then the final graph is showing how all aggregated together there, they are smoothing out the sort of power and load with the the sort of group control. So they're all charging slightly differently, discharging slightly differently, but overall it gives a smooth input onto the site. And next slide, please. And I think this is possibly the final one. So Nottingham City Council is a very interesting project. Again, it's doing a number of different things. It's supporting EV charging. But one of the key things on this site is they have vehicle to grid capability on their EV chargers, and they're charging both cars, vans, and also electric refuse vehicles. So they've got a reasonable capacity of EV charging and EV batteries, and our battery system and the software we've provided alongside it is helping them to operate all of that as a single site and single battery effectively. And that, again, is generating revenues as well as operating and optimizing the site. Okay, and that's the end of my presentation. So yeah, happy to answer any questions afterwards.
Thanks, Jonathan. That was really interesting to hear about the diverse ways your systems can be used on site, and how there's a lot of work to do with optimizing sites, as well as then adding that extra bit of revenue on top as well to help the economics all work out. So I think we are now at the end of our speakers. Thank you everyone for putting your presentations together and preparing and coming and giving us your time today. We can open the floor now in the chat to anyone if they have any questions for speak to some of the examples that we had about how to optimize battery storage on site, or how to work with large wind turbines and get the most out of all of the different markets that they have available to them. Our speakers are around for a couple more minutes and we'd be very happy to answer any questions. So none have come through on the chat at the moment. I don't know if our speakers have any questions that they would like to come through, but okay, we have a question. So this is for Connected Energy. Connected Energy, using your former EV batteries, make a BESS, how do you go about procuring and maintaining them, e.g. warranties, etc.? So that's for you, Jonathan.
Okay, so currently the systems we're using are using batteries from Renault. We procure the batteries directly from the manufacturer, and that is a key part of our sort of strategy, and that allows us to both get the battery packs to a set specification, so they're tested by Renault before they come to us, so we know that they meet a certain criteria, and actually Renault also provide a 2-year warranty on the performance of that battery pack, and then we're able to offer a longer term warranty through an insurance backed policy. And it is our we use the batteries in the packs exactly as they come out the vehicle. We don't break the packs open, so we access all the controls and communication safety that the manufacturers have put in place. So that's the reason why we always want to go to the manufacturer directly rather than going to recycling or scrap vehicles or whatever, because we want to make sure that we've got access to those control protocols.
Great. I think that was a good answer. Kelly, I assume that's covered your question. I really like how we've got an example of second use batteries here, because I think it's really important. Obviously, it's exciting, all the new EVs coming on the market, but what's going to happen when they're no longer being driven around? There's still a lot of life in those batteries, and we can definitely use them. And I love to hear those stories. So thanks, Kelly. Is there any other questions for our speakers? Because we've got another couple of minutes that we can answer them. And then while I'm waiting for any other questions, I will just remind everyone that this is the third, and there is a fourth and final series in these webinar sessions that we're co-hosting with partners in the industry. The fourth one is going to be on the 7th of December. and that is with Energy UK. So if you yourselves or your colleagues are interested, this one's going to be focused on demand side response. So today's was wind and storage, as is obvious by our brilliant speakers, and the next one will also be looking at domestic demand side response. So any further questions? Otherwise, I will wrap up, and we will. But if you guys have further questions beyond, absolutely happy for you to email them into Piclo, and we can grab the relevant responses from our friends and get back to you. But if there, one more question for Jonathan: how did you decide which grid services to participate in?
So we don't operate any of our battery systems ourselves currently, although that is going to change a little bit going forwards. So we have discussed with the client what availability those systems might have for grid services, and then spoken to a number of aggregators who then provide the grid services and work out what they're going to do.
Just a follow-on question for that one, Jonathan. Did you run a particularly big tender process to choose which aggregator you went with? Because I know that there's a wide range.
No, not particularly. Actually, it's something we are working on, sort of widening our sort of reach to the aggregators. So for the previous projects, usually we've spoken to one or two, and then help the client sort of work out which is the best way to go. But we're sort of aggregator agnostic. We're happy to work with any of them. Yeah.
And I guess in the EDF case, you don't need to work with an aggregator because you guys have enough teams in-house to go direct to the markets. Would you say that's correct?
So we use EDF Energy, that's got the market access, and that's our primary source essentially, because we transfer all the volume over to them.
Yeah, so I think it's a good example of there being lots of different flavors of how you can take part, and you can partner with different providers. Like, I don't think one company has to do everything. We can also specialize, right? So be battery specialists and be market designer specialists and turbine specialists as well. So I hope everyone really enjoyed our speakers today. I definitely learned something, and I will just leave you with that reminder of there being a final in our fourth series for domestic DSR on the 7th of December, and that's partnering with Energy UK. So please do come along or share that with your socials so that other people relevant in the industry can come and learn from the excellent speakers as well. There's a last minute question, mention of API dispatch for the LCM. So is the API call and response coming from stroke to the ESO or via Piclo? Excellent question. I can answer this one, but also we can do that one together. It's coming from Piclo. So the ESO's control room, when they're running their market clearing on the day ahead or intraday, when they've done their maths and they're happy with the outcome and they hit kind of confirm, what that does is send the dispatch signals, and they can be received via both email and API, and EDF receive them. So it's kind of both.
And just to echo that, from our side, we only see the Piclo, so we communicate with Piclo, and then Piclo does the background work of communicating with the ESO and getting those things around. So for us, we only see Piclo.
Yeah, and the idea obviously with that is that EDF can take part in multiple of the DSOs and only have to have one API, and we do the admin and the hard work on the other side to have those connections in with the relevant system operators. There's a follow-on question there. You see this happening for other DSOs? Yes, is the short answer. Obviously, we have historically been running more long-term competitions with them, which haven't involved the direct need for dispatch. But there is obviously a really exciting shift in the DSOs to move to shorter term competitions, which then mean you've really got to actually go ahead and dispatch. And we will be providing some of them really soon. So I think it's all moving very quickly in the DSO space. And I would say that if you want to stay on top of like what's happening and when, best thing to do is to, if you haven't already got a Piclo account, is to sign up. Or come and talk to us about potentially getting more information. But we have a lot of sort of automatic systems built into Picklo to make sure that you stay up to date with what the latest competitions are, and we can also help you get us set up with APIs and everything to be ready for when competitions happen. So I think that is probably a good place to end. Thank you everyone for speaking. Thank you everyone for coming, and thank you for the questions, and enjoy the rest of your afternoons and days. Thank you everyone. Goodbye.